In this video, we will be learning about counters. Study of counters. Counter is a device which stores and sometimes displays the numbers of times a particular event or process has occurred, often in relationship to a clock signal. They can count specific event happening in the circuit. Counters are broadly divided into two categories: asynchronous counter and synchronous counter. Under the synchronous counter, we have ring counter and Johnson counter, also known as twisted ring counter. Ring counter. Ring counter is almost same as shift counter. The only change is that the output of the last flip-flop is connected to the input of the first flip-flop in case of ring counter, but in case of shift register, it is taken as the output. Number of states in ring counter is equal to number of flip-flops used. Circuit diagram. For designing 4-bit ring counter, we need 4 flip-flops. Input variables equal to reset and clock. X equal to clock can be either a positive edge or a negative edge. Output variables Q0, Q1, Q2 and Q3. Truth table. Reset state, clock state, Q0, Q1, Q2, Q3. So you can see by giving X in reset, 0 in clock, we have the previous state as such retained. By giving 0 in reset, 1 in clock, we get 1 in Q1, Q2, Q0 and 0 in Q3. Simulation for ring counter. In ring counter, we are using 4 D flip-flops, then 4 bulbs, 1 NOT gate, 1 clock pulse, 1 toggle switch, 1 push button and 1 high constant. We are giving the connections as shown and we are checking for the outputs as given in the previous table. This is all about the simulation for ring counter. Johnson counter. The alternative name of the twisted type is switch tail or walking or Johnson type counter. Complemented output of the ending flip-flop is feedback to the input of the starting flip-flop, where the stream of ones and zeros flow in ring form. The twisted type uses true control signals like clock and OR. And clock and OR are common to all 4 flip-flops. Block diagram of 4 states with twisted ring time counter as shown here.